Okay, this is test 2 review still, and let's scroll down. We're doing problems 13 and 14. Find all the factors for the number. And this is very important, the instructions. Find all the factors versus these down here where it's find the prime factorization. So know the difference between these two instructions. So I set up these problems, 13 and 14, and we're going to look at finding all the factors. That's what they're asking for. But I'm also going to look at finding prime factors so you can see it side by side. However, there is many ways to find prime factors, and I'm making other videos that show you how to find prime factors using a cake method, a tree method, and then the one I use on this one that you're watching now will be a fast method that's best for smaller numbers. If you have a large number, it's better to use the cake method or the tree method. So there's 3 ways to do it. So we're finding all the factors of the number 45, and what that means is any numbers that you multiply that then equal 45 are factors of 45. For example, 45 times 1, all numbers will start out with these 2 factors. Those are the first 2 factors, 45 times 1. So I like to go along in order. 1, now let's look at 2. Does 42 go into 45? Because will there be a number where you can say 2 times some number equals 45? Well, you can't say that, because 45 is not an even number, so 2 does not go into it evenly. You would have to move into fractions or decimals to get a 2 times something equals 45. But we're not talking about fractions or decimals. We're only looking at whole numbers. So 2 is not a factor of 45. However, you can use your divisibility rules and you go to the next number, and what I mean is I looked at the number 1. 1 times 45 is 45. I looked at the number 2. 2 times any number doesn't equal 45. Let's look at the number 3. How do we tell if 3 goes into 45? Our divisibility rules, which is add the digits of the number 45. 4 plus 5 equals 9. And then if that's true, 3 goes into 9, so 3 must go into 45. So what? How many times? Well, if you don't know off the top of your head, you have to do the math. How many times does 3 go into 45? 15. You have another set of factors. 3 times 15. Alright, we looked at 1. 2 is not a factor. 3 is 4 a factor? Well, the rule is if 4 goes into the last 2 digits, well, the number is only 2 digits long. But if we know that 11 times 4 is 44, then we can't possibly have 4 going into 45. So 4 is not a factor of 45. Is 5 a factor of 45? Well, it ends in the digit 5, so according to the divisibility rules, 5 goes into 45. And if you remember your times tables, 5 goes into 45 9 times. Okay, now we could look at the number 6. Does 6 go into 45? 6 times 7 is 42. So 6 times 8 is 48. So no, 6 does not go into 45. 7, we just did 6 times 7 is 42. 7 times 7 is 49. We're hitting either side of 45. We're not going to make it in as a 7. And 8 times 6 is 48. So 8 and 8 times 5 is 40. So 8 does not go into 45. 9, yes, 9 goes into 45, but we already have that there. And we could keep going, but at this point, we've hit this point. Now we know the next number above 9 that goes into 45 is 15, And the next number above 15 that goes into 45 is 45. So once you hit sort of a turnaround point, and this is your turnaround, 5, 9, and whoops, we're just going backwards, then you have all the factors of 45. So as we list the factors, you would list them 1, 3, 5, 9, 15, 45. So you would list it 1, 3, and some programs, some math programs, make you list them in order, in number order. They won't accept them listed out in this order. So those are all the factors of 45. 1, 3, 5, 9, 15, and 45. Okay, so let's look at number 14, and let's get some of this stuff out of the way. So we're looking at all the factors. We're going to ask ourselves the same questions as we asked up here. We're going to look. You can start with 1. Does 1 go into 70? Of course 1 goes into 70. 1 times 70. There's our first set of factors. Okay? Does 2 go into 70? And let's start our little tally down here. Does 2 go into 70? 70 is an even number, so according to the rules of divisibility, 2 does go into 70. So our next factor is 2 times some number. Well, if you don't know for sure, then you do the math over on the side. Well, let's see, 2 into 70. I happen to know the number is 35. Now, you would go to the next digit, 3. Does 3 go into 70? Well, the divisibility rules are that if you add the digits, 7 plus 0 equals 7, and decide by looking at this number, does 3 go into 7? No. So 3 does not go into 70. So that's not a factor of 70. What about the number 4? Well, not many people know your multiplication tables of 4, up that high. So I already worked this out, so I do know the answer, but let's look at it. Because if you were on a test, you would have to sit there and go, okay, does 4 go into 70? Well, let's look at it. 4 into 7. Here's 1 times 4 minus 3. 4 into 30? No, because 7 times 4 is 28, and 8 times 4 is 32. So 4 does not go into 30 or into 70 evenly. You will end up with a remainder. So no, 4 does not go evenly into 70. So then you ask yourself, does 5 go into 70? Well, the rules for 5 are if the number ends in 0 or 5. So 5 does go into 70. Once again, you're thinking, 5 times what is 70? So you have to work out the math. 5, and it's a little frustrating because if you had a calculator it'd be so much easier, but on the test you won't. So 5 into 20 is 4, so we have learned that 5 times 14 is 70. So that's the next factor. So notice we've got these two factors, 1 times 70, 2 times 35. We didn't find another factor until we hit 5. And now that's 5 times 14. And basically we're going to look for our turnaround point. Now you have to ask the question, does 6 go into 70? Well, 6 times 11 is 66. So I don't think 6 is going into 70. 6 times 12 is 72. So 6 does not go into 70. Now does 7 go into 70? Well, it sure does. 7 times 10 is 70. 7 times 10. Okay. And then you would go to 8. Does 8 go into 70? Well, 8 times 10 is 80. 8 times 9 is 72. So 8 will not go into 70. Does 9 go into 70? 9 times 8 is 72. You still have that problem, and in a sense you've kind of hit a turnaround. Here's the real turnaround. Now you have 10. we've already found a 10 that goes into 70. So that's the turnaround point. And at this point, you've got factors 1, 2, 5, 7, 10, 14, 35, 70. So you would list them out that way. 1. And those are all the factors of 70. Now if you were to compare that, and let's clean this up a little bit. So let's look at the prime factors of 45. How I do it, this is a quick way to do it, and it works for 2-digit numbers. Once you're getting into 3-digit numbers, this way might not be as effective. What I do is I take 2 of these factors. I'm going to use 5 times 9 because I think that's a very common one that we know. 9 times 5 is 45. Okay, and I look at those 2 factors I've created and I realize, okay, one is a prime number. I'm going to circle the prime number. This is not a prime number. Remember, a prime number is only 2 factors, itself and 1. 9, really quick, has 9 times 1 and 3 times 3. So it is not a prime number. You still have to break this one down. So you do that. You break that number down. 3 is a prime number. So you circle the prime numbers. 3, 3. And this is your prime factorization. 5 times 3 times 3. So we'll write that out. And that's supposed to equal 45. If it doesn't, you made a mistake. These are all prime numbers, so they're considered prime factors of 45. These, 1, 3, 5, 9, 15, 45, are all the factors. And all the factors are not all prime numbers. They have the prime numbers in them. 3 and 5 are prime numbers. 1 is neither prime nor composite. But there's also this, 9 is a composite, 15 is composite, 45 is composite. So these are all the factors. These are just prime factors. And you can double check that. Multiply it back. 5 times 3 is 15 times 3 equals 45. And we just did that up here. So if we looked at the prime factorization of 70, and I'm going to do it my fast way. Okay, so I know that 7 times 10 is 70. I've got one prime number. So I'm done with that. I don't have to break it down. This is still composite, so I need to break it down. 2 times 5. 2 and 5 are both prime numbers, so we circle those, and we're done. So the prime factorization of 70 is 7 times 2 times 5. And those are all the prime factors of 70. And these here are all the factors in general of the number 70. So these have both prime numbers and composites, and this is just prime numbers for factors. So prime factors and all the factors. Okay.